What's up, everybody? Let's get back into our interpreter here. So we were working on the resolver, and last time we made it to right around here, resolving variable expressions. And let's just remind ourselves what we had. So we had we can resolve block statements and variable declarations. Let's look in statement. So now we need to resolve expressions, variable expressions, which I think we have a function for here. Yes. And actually we already did that. So I'm remembering wrong where we stopped. And probably it was actually here. Let me see. Yeah, so this, no, this function we also have. So is it this one? Finally, functions both bind names and scope. The name of the function itself is bound in the surrounding scope where the function is declared. When we step into the function's body, we also bind the parameter. Okay, I think it's this one. So it corresponds to this statement type or variant. So let's try to implement that. So we get a function, and let me just see its fields over here, which has a name, parameters, and a body. And as always, we will just make a helper function called resolve function, and I will put it down here. Okay, let's see. Okay, first we have to unwrap it like this. Name, parameters, body. I feel like there should be a better pattern for this. But whatever. So first we need to declare it. Declarations take the name. Then we define it. And define also just takes the name. And then we call another function. Similar to this, we declare and define the name of the function. Unlike variables, though, we define the name eagerly before resolving the function's body. This lets a function recursively refer to itself inside its own body. Sure. Then we resolve the function's body using this. I'm not going to make a separate helper function. Rather, I'm just going to do it here. We make a new scope, and then we say for parameter and params. And so we declare and define all those parameters, and then we resolve the body. See if that more or less compiles. It's not XC. Right, so we have to say resolve many. Mismatch types if let's think. Okay, and then we have this resolve function and the interpreter that we still haven't written yet. Okay, so he says here that it's a separate method since we will also use it for resolving logs methods when we add classes later. So I am actually going to pull it out anyway. And what do we call it? We already have used resolve function. We can call it, I don't know, resolve function helper. And it takes the statement. And unfortunately we need this again and this again. And here we just want return value and then we're good to go. Okay, now we need to handle some more things. So if we have an expression statement which just has an expression, then that is easily handled by our existing method. Okay, and then there is if statements which have these things. And remove that, put it to do just to get it formatted. And maybe I will put it here. So, well, no, let's not break with the pattern. So resolve if statement. We'll need this thing again. Okay, so first we have to resolve the predicate, which is an expression. Predicate. Then we have to resolve the then branch, which is a statement. So we'll do that. Now it takes a reference, so we can just put as ref. And if let sum else equal else, which is a box statement again, we can just resolve that thing. And if all goes well, it's okay. And we're good to go. So then it's time to resolve the print statement. We go back up here. Statement print. And again, print just has a single expression. So we can do that. And a return statement. Let me see, just to check. It has something called a value. So can I actually do return statement keyword don't care, and if the value is none, then we don't do anything. Actually, we just return OK. And then we do the same thing, but if the value is a sum value, we just shadow it, and then the value is again an expression. So solve that. And let's check that that works. This and all priors. Okay. Interesting. Okay. So then it's while statements. Let me check here. It's called while STMT. And again, that has a condition and a body. And here, because it's so simple, we will say resolve the condition and resolve the body, which is a statement, as a reference. That still good. Okay, now there's some expressions we need to handle here in resolve expressions. So if it's a binary, what do we then have? Let's see, an expression, binary, left operator right. I guess we don't need that, so do it like this. And because it's simple, we will just say resolve left. And that's it. Check it still works. Does not work. Okay, we do this. Okay, let's look into the calls. We walk the argument list and resolve them all. The thing being called is also an expression, so that gets resolved too. Let's have a look. As a callee, a parenthesis and arguments. So callee parentheses, we don't need arguments. And do that. Then we say for arg and arguments. And what is an argument? It's also an expression. So we resolve those. And then we have to return OK. Still good. And then we also, to make the compiler happy, we have to visit grouping, which, by the way, has an expression inside. So I guess we just call expression resolver. And literal, is it called literal? Yes. That is always okay. Then we have a logical, which has left operator right. Don't need that, I think. Do need that. It's a little bit simple or easy. And then unary. So what does unary have? It has an operator and a right. Now he says it's the last one, but actually we also need to cover this node. So let me see. Maybe this resolve function helper will now be useful. No, but we definitely need to do something quite similar. So if you bear with me, and no, actually, why don't I put that one there, and then I go down here. Okay, now, if it is an anonymous function, then we go up here. It has a parenthesis, which we don't need. It has arguments. And okay. Anyway, and it has a body. So, I mean, I basically want to do this. And yeah, I mean, I think it's exactly that. The annoying thing is just that maybe this resolve function helper will instead take params, which is a vector of tokens, and probably reference to a vector of tokens, and then the body, which is a reference to a vector of box statements. And then we can also simplify it by doing this. And we don't, well, this resolve many can return an error. So actually we need to do this and this and format and okay. And now we can reuse it over here, call solve function helper on the arguments and the body. And we check it. And there's an error because we don't need the comma. And actually let's do this, and then we do need the comma. And then we need to fix up this line to just take the params and the body. And 184, let's see. Right, we don't unwrap it if it's the last thing. Now we're good to go. So we're beginning to diverge a little bit from the book, which is of course, well, that's because we had that extra, we did that extra task that that wasn't like part of the main thing. So maybe it's okay. Let's do that. See that it doesn't complain. Doesn't complain. With all of these visit methods, the Java compiler should be satisfied that Resolver fully implements statement visitor and expression visitor. Now is a good time to take a break, have a snack, maybe a little nap. Maybe it is. Maybe it is a good time to take a break. So we basically just filled out this function. And I think we're also covering every statement here. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. And we also have 8 here, if I'm not mistaken. So we can remove that, and then we can say that's fully implemented. Just check again. And just, what am I doing when I do that? I'm just letting the compiler, no, it doesn't, normally it should say that it's not covering everything. But maybe that's because of the other interpreter compiler error. Anyway, so we'll continue with this in the next video. Thank you for watching.